Welcome to Aurora Chemistry for everyone. Certain compounds can be expressed in more than one Lewis structure, and these structures are equivalent in position of their atoms but differ in the position of electrons. These structures are called resonating structures and the effect is called resonance effect. For writing resonance, we need to follow certain rules. According to the rules, position of atoms in a compound should remain same. Only electrons can move. At the same time, total number of paired and unpaired electrons should be same. If charges are present, negative charge should be present on electronegative atom. To write resonance structure, first we need to write Lewis structure. So here are the steps we need to follow to write that Lewis structure. Look at the first step, skeletal structure. When you draw the skeletal structure, see the step 2, the center should be less electronegative atom. In O3 Ozone is made up of 3 oxygen atoms. So we can write that 3 oxygen atoms just around 2 other oxygen atoms. Step 3, count valence electron. So we go to count valence electron. There are 3 oxygen atoms. So 1 valence electron of oxygen, 6. So 6 into 3, 18 valence electron should be present in this compound. Now look at the step 4, single bond between all the atoms. So we go to draw the single bond between all the atoms. Single bond means 2 electrons are involved. After that, step 5, double or triple bond for central atom. Why we are going to put the double or triple bond around central atom means to satisfy octet rule. So for oxygen, valence electron 6. So we can draw that electron dot structure 1, 2, 3, 4, 5, 6. That means 2 lone pair electrons and 1 unpaired electrons are present. These unpaired electrons can participate in covalent formations and these 2 lone pair electrons can form coordinate bond. But oxygen is highly electronegative, so due to that reason, oxygen can form that only 1 coordinate bond. So totally we can expect that 3 bonds. Already we have drawn 2 bonds, so we can draw that 1 more bond. So this bond is a coordinate bond. So remaining 2 electron, that means 1 lone pair electron is present is needed, so that we can keep it like that. Now check that oxygen 2, 4, 6, 8. So central octet, octet is completed. Now come to that step 6, octet for highly electronegative atom. So here oxygen is highly electronegative atom. Here let us see that first this corner oxygen atom 2, 4, 6, 8. For this central atom, octet is completed. So we can move to this one 2, 4, 6, 8. Let us count the total electrons, 18 valence electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18. So 18 valence electrons are present. You see that step 7, duplet for hydrogen. Anyhow, ozone does not contain hydrogen. Then some exceptional cases are there. Expanded, sulfur, fluorine, chlorine, bromine, iodine, they all are expanded case. Then deficient, lithium, beryllium, boron, aluminium, then odd electron system. But that here ozone does not follow any other exceptional cases. So now this is that one Lewis structure. Let me draw that the same thing here. There are 3 lone pair electrons are present on this oxygen. So this is electron rich oxygen. So the electron movement can take place from here. So when this electron moves, this will form a double bond here. When it forms double bond, then 2, 4, 6, 8, 10. Then oxygen will get 10 electrons. It's just like violating the rule. So that's why this double bond break and form 1 lone pair electrons here. Let me show here. So to draw that, first write that oxygen atom, oxygen, 3 oxygen atom. So you go to show that now double bond here. The same way here the double bond is breaking. So now we have the 2 lone pair electrons here. Then but that here we are getting 3 lone pair electrons. Then central oxygen also contains lone pair electron. Let us count that 18 valence electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18. So 18 valence electrons are present. Any other possibility is there? No, we cannot move that. Further moving this lone pair electrons here, then we will repeat the same structure only. So these are the two resonating structures of ozone. So these resonating structures can be represented by that double-headed arrow. So these are the two resonating structures of ozone. Thanks for watching.